let me ask you what are general equations? What do you understand by the word equations?
It's like a linear equation kind of
Yes,
equation.
linear equations, quadratic equations. So equations is anything that contains an equal to. This is must have. You must have equal to say that it is an equation. With equal to, you can have variables. Variables are those numbers which change their values, like x, y. You can assign any value to x and y. There can be constants. It is not necessary to have constants like the equal to, but there can be constants, and can be some other functions like trigonometric functions or whatever. So a simple equation is like that: a equals b plus c. So now what is differential equations? So when you introduce a derivative in this equation, it becomes differential equations. So differential equations are like this: dy by dx. This means we are differentiating uh, independent variable a dependent variable with respect to independent variable. Now let's quickly see what these two terms are. So let's say we have a function y equal to x plus 2. So you can see here, as we change the value of x, suppose x is 0, so then what we get y equals 0 plus 2 or 2. So and let's suppose next we have x equals to 1. So we get y equals 1 plus 2, which is 3. So we can see, as we are changing the value of x, the value of y is changing also. So we can say here that the value of y depends upon the value of x. Hence, y is the dependent variable and x is
Yes.
the independent variable. So in a differential equation, we have something like a derivative and a function. So this is a general form of differential equation. Okay. So
Yes.
in this unit, I'll have to take a look at the concept map, because it tells you how much you have to learn in a unit. So in this unit, we are going to learn order and degree. First, we have talked about differential equations. What are differential equations? Next, we will learn order and degree, solutions of differential equations, formation of differential equations, and next is modeling. So let's first see what are order and degree of differential equations. So what is order of differential equation? So the order of differential equations is the highest order of derivative in it. So now we must have a question: what is order of derivative? So what is order of derivative? Order of derivative is how many times you have differentiated the dependent variable with respect to independent variable. For example, let's see derivative dy by dx. So in this case, we have only differentiated the variable y once with respect to x. Okay, this is just differentiating one time with respect to x. So here the order of this derivative is 1. Next, we can see, if we take d2y by dx2, this means what we have done, we have taken dy by dx and again differentiated it with respect to x to get d2y by dx2. So here we have differentiated twice. So the order is 2.
Two.
Similarly,
Yeah.
we'll see in the differential equations. Suppose we have a differential equation like this: dy by dx plus d2y by dx2 equals to 5. So here we can see we have a derivative here which is differentiated only once. So the order of this derivative is 1. And here we can see we have a derivative which is differentiated twice with respect to x. So here the order of this derivative is 2. But when you say what is order of differential equations, so what is the order of this complete equation? So we'll see the highest order. So which one has the highest order? This one has the highest order. So we'll say the order of differential equation here is 2.
Two.
Okay. So now,
Laya, yeah, sorry to interrupt. Laya, if it is going very fast, you can just tell sir to slow down, and if any
Oh, yeah,
problems
sure,
occur.
sir. It's going in the perfect speed.
Okay, okay, yeah.
okay, so now
Thank you.
let's do some questions where we have to determine the order of the differential equation. So in the first question, we have a uh, derivative which is differentiated only once. So in the first case, what will the order of the order of the differential equation? It will be 1.
1.
Okay. Now in the next question, we have two derivatives. Once a variable s is differentiated with respect to t, and in the second derivative we have a variable s which is differentiated twice with respect to t. So what will be the order here? Can you tell? Can you tell?
2.
Yes, 2. Because we don't have to look at this, because this is the highest
Yeah.
derivative here. Similarly, in this case, what will be the order?
2.
Yes, 2. Because we have the derivative of second order here. Now let's see in this case. So here we don't see any derivative in the form of dy by dx. There is no dy by dx here. So one thing is what we can do, we can change this equation into dy by dx form. Okay, so how we can do that? So first let's see, we have two dy's term here. So what we can do, we can take common, taking dy as common. So if we take dy common from this term, what is left? X log y by x. And what is left here? Minus 2x.
2x.
Now we can shift this y dx over here. So this becomes dy times x log y over x minus 2x equals minus y dx. Now we need to calculate dy by dx, which means we have to get this dx over to the left side. So we can divide both equations by dx. And in the next step, we can just shift this into the right hand side to get dy by dx gives minus y over x log y by x minus 2x. So now we have the differential equation of the type dy by dx equal to something. So here we can see the order is 1,
1.
right?
Yeah.
So next comes what is degree of differential equation. So these two things are asked simultaneously. They'll give some questions and ask what is the degree and what is the order of differential equations. So the degree, so you have to remind yourself of two things, that degree is related to order and degree means power. Okay, so what is order means here? That we need to look only for that which is of the highest order. Like in the previous example we were looking at, in the second example you can see we looked at d2s by dt2 because this was highest order. So when we are looking for degree also, we will go with a derivative which has the highest order. And next what we will do, we will look what power it has. So let's do same questions which we used to determine the order. Let's now calculate degree also. So in the first example, we can see the degree of the differential dy by dx is 1 because the power here is, we can write this at this, the power is 1. So degree is also 1. Now in the second case, we can see we don't have to look at this, the first variable. We only have to look at the second derivative. So here the power is what? Power is 1. So degree is 1. Can you tell what is the degree in third case?
Is it 2?
Yes, it's 2 because we don't have to look at this because when finding order we have taken this quantity, and the power, the exponent that it possesses is 2. So the degree is also 2. Here also we can see at the last step we have power 1. So the degree is also 1. Okay.
Okay.
So our degree and order both, have you understood both of them?
Yes, sir.
Okay. So as you can see, we have completed differential equation, what are differential equations, and we have understood what are order and degrees. So next we'll move on to solution of differential equations. That is how we can determine the solution of differential equations. So the differential equations are formed by derivatives. So what will the solution? The solution will be got by, we can determine the solution by integrating. Okay, because in the solution, what we have to do, we have to determine y or x. So how we can change this dy to y? It's only through by integration. So in every differential equations, when you have to solve the differential equation, you are going to integrate it. The methods can be different. There are different types of differential equation, but the general thing is the same for every case, that if you have a differential equation and if you want to solve it, you're always going to integrate it in some way or another. So now let's first see equation of the type this: dy by dx is x over y. So actually the first method is variable separable. So as the name suggests, what we are going to do, we have to separate the variables. How we are to separate the variables? So we have four quantities in a differential equations: dy, y, dx and x. So how we are going to separate? We are going to separate these two quantities together and these two quantities together in whatever way we can. Either we can cross multiply them, either we can plus minus them, or we can change from left hand side to right hand side. Whatever the case, we are going to take dy and y together on one side and dx and x together on the other side. So let's see how we can do this in the first part. So in the first part, we can see if we cross multiply this equation, what we'll get: y times dy equals x times dx. Okay, so now we have separated the variables. We have separated y over one side of the equation and x over other side of the equation. Next, what we can do, we can integrate them. So let's integrating both sides. So integrating both sides will get y dy equals integrate x dx. Now what will the integration of y dy? Can you tell me what will be the integration of y dy?
Will be y squared divided by 2.
Yes, it's be y square by 2 equals. Similarly, we can integrate x dx, which will give x square by 2. And
X
since
squared
it
divided
is
by 2.
a, yeah, since it is a indefinite integral, which means we don't know the limits of the integral, we're going to add a integration constant c. So here we have the solution of the differential equations. So the solution of differential equations must be eliminated from the derivative. So we have dy by dx over here, but if you look at the solution, we don't have any derivative now. So this is the solution of differential equation. So let's do one more. We have dy over dx is e to the power x plus 1 times y. So we have to do the same thing. We have to look if we can separate the variables. So here also we can separate the variables by cross multiply. We need this y over or to the left side and we need dx over to the right side. So we can just multiply these two together. So dy over y gives e raised x plus 1 times dx. Now again we can integrate both sides. Now what will the integration of 1 over y dy?
A log y.
Yes, so 1 upon y dy is log y, and here we can break the integral as e raised to the power x dx plus integration of dx. So what is the integration of ex?
Ax.
Yeah, ex is just e to the power x. And what is the integration of dx? Actually it is 1 dot dx. So what is the integration of,
X.
Yes. So we'll get x, and since it is indefinite, we're going to add a integration
Plus
constant
C.
c. So this will be the solution of our second differential equation. So here we have another problem. So it's similar to the first one. It's just we have some exponents on y and x. So we can do the first step of separating the variables. So dy over y raised to the power 5 gives minus dx and x raised to the power 5. Okay, we have just
Yeah.
we have taken x here and y here. So now we can integrate both sides. So how can you integrate 1 over y raised to the power 5?
Will it be log y to the power 5 again?
No, here we can use the integration of, you must have seen this formula, x raised to the power. When we have a polynomial function with some power greater than 1. If
Oh,
it was 1 upon y, we were saying that it is log y.
log.
That's correct. But if we have a polynomial function of degree greater than 1, let's say we have 1 upon x square. So now we cannot say that this is log x, going to be log x square. Now we are going to
Yeah.
use the formula for x raised to the power n dx. So what it says that you need to increase the power by 1 and you're going to divide it by the same. Okay, and the integration constant c. So we can write this as y raised to the power minus 5 dy,
Minus 5. Yeah. So
and
it'll be
here we
y
can,
to the power minus 4.
yes, so we can add 1 to the power, which will give y raised to the power minus 4, and we can divide it by the same. Here
Minus.
also we can do minus 4 by minus 4 plus integration constant c. So this minus cancels out, and we can change this y, we can multiply the whole equation by minus y to get y raised to the power minus 4. It is minus 4x raised to the power minus 4. Actually minus 4 and 4 will cancel out. We have 4 here also, so it will just be minus 4 plus c. So this will be our solution. Can you tell me, there might be some error in this solution? Why we haven't changed the constant c? Why we are not writing 4c? Because we are multiplying by 4 in both equations. So what we did, we multiplied 4 by here, minus 4 by here actually, and we multiplied minus 4 here, and we should multiply minus 4 here to get minus 4c, no?
Yeah.
So is it wrong to just write plus c here?
I don't think so because we don't know what the constant is.
Yes. So we have a, let's say we have a constant c. Now if we multiply c by another constant, which is minus 4, so we'll get one more constant. This it may
Yeah.
be a different constant, so we can write d, or we can just take it c. So whenever we multiply the equation, because sometimes what happens is when you look at the answer behind, it will give something else. So the thumb rule here is whenever you have to change the equation, like here we are multiplying 4 by in the complete equation, so only do that when you are approaching your final answer. Let's say if this was occurring before some step, so you will just leave it like that here if you get it in earlier steps, and you will only change this in the final step. Okay, in the upcoming question we'll see what this means. So now let's talk about the types of solution. So there are two types of solution that we have to study. The first one is general solution, and the second one is particular solution. So let's see what these both are. So until now, the questions that we have solved all gave us a general solution. Why? A general solution is of the type, let's say we have some x and y, And with that, we are going to have some constants in it. These are called arbitrary constants. The one we are writing at the end are the arbitrary constant. Here you can see the plus c is arbitrary constant. So whenever we have arbitrary constants in our solution, we're going to say that it is a general solution, because we don't know what that c, what the value of c is. It might be 1, it might be 2, it might be negative. So the solution is just generalized for all values. Okay, unless we know the values of constant, we don't know what exact solution is. So whenever we have arbitrary constants in our solution of the differential equation, we say that the solution is general solution. Otherwise, if we are given some conditions and we are able to determine what exactly that constant was, what exactly the value of that constant was, then we say that the solution we acquired is particular solution. So the particular solution will be only x and y type, because we are replacing c and d by some value 1, 2, 3 and so on. So the particular solution will be like fxy equal to 0. So this will be like our particular solution. So in this case, we do not have no arbitrary constants. We do not have any arbitrary constants in our solution. Okay. So this was about general solution and particular solution. Let's quickly see what our next topic was. So which book are you currently studying from?
ML Agarwal.
ML Agarwal. Okay. So after the session, if you want to continue with the session, please send me a copy of the topics before our class so that I can arrange the topics. Okay.
Oh yeah, sure.
Okay, so we have completed general solution and particular solution. And next, see, we have the formation of differential equations. So how we can form the differential equation. For this, let's take a so I have your book here. Let's see. So in the first exercise of the unit, we have questions from order and the degree of the differential equations, which I think will be now easily doing those. So let's see what were the questions. So we have done these types. Let's see the last type. Can you tell what is the order and degree of the differential equation, fifth differential equation?
The order is 3 and the degree is 2.
Yes, right. So we have completed exercise 1. Let's move on to exercise 2. So this is the another type of question that you will be getting. So verify the given function is a solution of the corresponding differential equation. So we have to verify that the solution given corresponds to the differential equation. So how do you verify a solution? Not just in differential equation. How do you verify a solution of an equation? You just put the solution into the equation to check whether it satisfies the equality. So let's see, let's say we have a equation like x plus y equals to 2, and we are given a solution of the form 1, 1. So what we have to check the solution. So what we will do, we'll put these values into the equation. So we'll put x equals to 1 and y equals to 1 to check if this satisfies. So this satisfies, hence 1, 1 is a solution of the equation. So similarly, when we have to check for the differential equation, we'll do the same thing. So let's take first question into our whiteboard. So we have a solution given y equals a e raised to the power minus x, and the differential equation is dy over dx plus y gives 0. So this is the solution that we have to check for the differential equation. So in the differential equation, you see there is a term y and there is a term dy over dx. So we know what y is, but we don't know what dy over dx is. So what we can do, we can differentiate our solution. Differentiate with respect to x to get dy over dx. Now a is constant, so you'll write a as it is. Now e raised to the power minus x. What will the differentiation of e raised to the power minus x?
Minus e to the power minus x.
Minus e raised to the power minus x. Okay. So now we have y and we have dy over dx. So all the variables that are occurring in the equation are now known. So we can just simply plug in the values to check whether it satisfies or not. So let's put dy over dx as minus a e raised to the power minus x, and for the y let's put a e raised to the power minus x, and you can see these both are same terms but with opposite sign, so it will give 0.
0.
So we have checked that the solution is for the differential equation that was given. So that's how you can check the solution. Now let's take some difficult ones. Let's see, we have this sixth one. Okay, now we have a solution as x square plus 2y square. X square equals 2y square log y, and the differential equation as x square plus y square times dy by dx minus xy. So what we have here, we have x square, we have y square, we have dy by dx, and we have xy. So first we can solve for dy by dx by just differentiating the solution. So differentiating with respect to x once to get. So what will the, let's write this dy by dx, x square equals dy by dx 2y square log y. Okay, so what we will get on the left side if we differentiate x square?
2x.
Yes, we'll get 2x. And how can we differentiate the term on the right side?
Product rule.
Yes, we have to use the product rule because we have two different functions of y. One is y square and other is log y. So what is the product rule? So if we have to differentiate two functions, then what we can do, we differentiate first and write the second function as it is, du by dx, and then we write the first function as it is and we differentiate the second function. Okay.
Yeah.
So here we can just take out 2 outside because it's just a constant. Now let's differentiate, let's write log y as it is, and let's differentiate y square. So y square will be 2y. Now we are
dy by dx.
differentiating, let's see, let's dy by dx of, we are doing y square. So do you think we can differentiate y square with respect to x?
No.
No, we must have a we must have
Y.
something of function of
Same.
x to differentiate with respect to x.
Yeah.
Then only we can differentiate, otherwise we can't. So what we can do here is do it like this, d by dx of y square. So we multiply it by dy and we divide it by dy. Okay. In the next step, we interchange these dx and dy to get d over dy y square into dy by dx. So now we have the derivative over y square with respect to y. So this can be performed to get 2y, and we get dy over dx as it is. Okay.
Okay. Yeah, got it.
Yeah, so you have to do it like several times in this unit. So whenever you are differentiating something, but the variable you're differentiating it with respect to is not the variable in the parenthesis, so there you cannot further follow. Okay, so y square gives 2y and dy by dx.
dy by
Similarly,
dx.
Similarly, let's write y square as it is. And now we have to differentiate log y. So log y gives 1 over
1 by
y. And we are differentiating y
y
with
cap.
respect to x. So we'll get dy over dx.
Yeah.
Right? So this 2 and 2 just cancels out. And we get 2 log y into y dy over dx plus this y and this y cancels out. And we get y dy over dx.
dx.
Now we can take dy by dx as common. So taking dy over dx common, we get 2 log y plus y equals to x. This gives us dy over dx as x over 2 log y plus y. 2 log y, there was 2 y's. 2 log y into y. 2y log y. Okay, so this is the value of dx. Now we have the value of dx. We can just simply put it here in the equation and simplify to get to see if the equations on LHS and RHS matches. So let's do that. So equation was x square plus y square times dy over dx gives
Is it minus xy?
minus, yes, minus xy gives 0. So x square plus y square. Now we are going to put dy over dx value. So what was dy over dx? X over 2y plus
log
2y log y plus y minus xy equals 0. So let's solve it further. But as from just seeing it, we can tell that the equations will not be equal to 0 because we have a log term here and we don't have a log term on the second term. So no way that's going to be 0. Let's further solve it. So we can multiply x to get x cube plus xy square over 2y log y plus y and minus xy equals 0. Now we can take the LCM also. So we will get x cube plus xy square minus xy times 2y log y plus y. And the term in the LCM goes to 0 to become 0. And we can see there is a term of log y which is never going to be cancelled out by any other term because we don't have any other log y. So this will never be equal to 0. We can say here. So the solution given was not of the differential equation that was provided. So not a solution. Okay. So that's how we can check the solution, whether it's from the differential equation that is provided or not. So let's see.
Rohan, I think that's enough for the demo purpose. Laya, if you have any questions, you can ask to sir, or we can just wind up, right?
Yes, please please feel free to ask me any questions. Yeah.
Yes.
Yeah, I have this one doubt. When I'm solving the differential equation, how do I know if I'm looking for a general solution or a particular solution?
Yes, so whenever you see, let me, so if you're seeing a equation, if you're seeing a differential equation, let's say dy over dx plus y equals to x. So first of all, it will be given that which solution are they asking for, whether they want you to determine general solution or particular solution. In case of general solution, sometimes they just say that solve the differential equation. So whenever you just solve the differential equation, you're definitely going to get a general solution.
Okay.
And if you want a particular solution, then there must be some conditions given, like when y is 1, x is 0. So this is just like one condition. Sometimes it is written as like this. This means that at x equals to 1, y is 0, the same thing. So you put these conditions into the general solution, and then only you can solve for particular solution. So particular
Okay.
solution comes from general solution after you put some values in the general solution and solve for that c, which we were getting. And when you put the value of c into the general solution, you'll get the particular solution.
Okay. Got it.
Okay. Yes.
Yes.
So that, I think that will be all for today. Please feel free to share your feedback. How did you like the class, or what you did not like, and we can definitely work on that to improve it in the next time.
Yeah, I liked it a lot because it was like perfect for my speed. Because the school, my teacher like teaches like super fast, and she just rushes through the portion, and half the things I don't understand. But this class, I understood a lot of things I was lacking in before. So thank you.
Yeah, okay. Thank you for coming today.
Thank you,
Thank you,
sir.
Rohan. Thank you, Laya. Thanks. Bye.
Thank you, sir.